Hello and welcome back to the first from the field. Was episode 4, 2023. I hope everyone had a good Christmas and a New Year and a good break to recharge. Yeah, Imran, did you get up anything over the holiday break?
Oh, let me introduce myself. Imran Sadiq. I am one of the senior solutions architect working with Casey. So yeah, Happy New Year if I can still say that. It's not end of Jan, so I probably can. What did I get to? Just relaxing, spending time with family, and just going around the country and spending some, quality time with kids.
Nice. Yeah, I did a whole bunch of nothing, and then I just spent probably like a week catching up all of the chores and everything that I neglected. But you have to live the good life occasionally. But and just for some housekeeping as well, I guess that if people were watching us last year, we have moved time slots slightly by 30 minutes, time zones, and because this is obviously a channel that is, have shows that from all over the globe, New Zealand being one of them. Like that's from where New Zealand's from, from the first run from. So there's been lots of time zone clashes and everything like that. So I'm writing a whole program to sort that in the background as well. So hopefully this is where we're going to stay for the rest of the year. So going on that front, because we're doing better than last year, we're actually starting in Jan rather than I think our first show last year was March, which is not ideal. And yeah, just to keep a tradition, we're kicking off with a lovely introduction to Cloud, so Cloud 101, because as I know that a lot of people, are stepping into even new roles because it's quite. I think the New Year is actually the most common time of the year to actually change jobs for obvious reasons, over Christmas, you're like, actually, this isn't worth it. Let's try something different. So, in that theme, I thought, doing the kicking the year off to Cloud 101 would be a great start. So, Imran, do you want to jump into it now?
Cool. And yeah, just adding on to Casey's words, it is also good to get a bit of refresher. So if you already are familiar with Cloud, it's always good to, recap some of the things before you get into the year.
And we'll try to add lots of stories and keep it interesting rather than, going through a boring, deck one by one. Because no one's interested in that. And I'm sure it's how I don't want to fall asleep. There we go. We'll just chuck that in there. Boom.
All right. So just confirming you can see my screen.
Yeah, it's all there.
All right. Okay, cool. Let's get started. So cloud computing with AWS. So I thought rather than just, talk about cloud and AWS directly, maybe we can, go back in history a bit and talk about how AWS came to be or how the cloud was sort of invented, right? So I'm talking about 1990s. So if we go back to that era, and I still remember I was 98, was a teenager, and the biggest thing that came out was internet and how it is going to change the world, right? The biggest advantage that we saw at that time was, how you can access the world's knowledge and access the libraries around the world, and that was fascinating. Um, and we all know about the dot-com era and the bubble bursting and everything else that went with it. So in 1990s, IT pretty much overpromised and underdelivered, right? That's what the 90s were famous for. And 2000s, social media came along, new businesses were formed, and everyone was talking about
MySpace,
Facebook. Oh yeah,
MySpace, and I
MySpace
think
starting
Echo
with
was
that.
there too. I think MSN was even like in there, but I think that was more of a chat client. I still remember like adding the themes and stuff to my Bebo page. Cringy
Yeah.
years of teenagers.
True, right? So that was good time. And technology matured that time, isn't it? I mean, we could actually see something like MySpace and Facebook. They were global services. They were global cloud applications that you could actually access from anywhere, and they gave you really good experience from that perspective. But if we talk about our local businesses, enterprises, even SMEs, IT was still considered as a cost, right? It wasn't a business enabler as such. It was just like, hey, I need to have an email, so I need to buy email server, and I need to be productive, so I need to buy some kind of a productivity suite of applications. I need to buy, computers for my staff so they can be more productive. But it was always cost. And one thing I remember is everything around that time. the IT itself always reported to the CFO, right? There wasn't any role around the CDO and from technology perspective, it wasn't around a separate pillar. It was under the cost pillar. It was a CFO role who was managing that cost, because it did cost quite a bit, right? But one thing it again missed was that it wasn't seen as a strategic enabler. And if you look at the 2010s, and that's when technology actually matured, and that's when everyone realized that it can be actually an innovation enabler. It's not just a cost to the business itself. And that's when we see the use of the cloud itself as well, and how people can create different businesses as well as innovate within their existing business using these technologies itself. So this is just a bit of a recap of the history itself.
And most
So,
people, a lot of people around today will actually only know of the era of the 2010s, essentially.
yeah, that's true. Yeah, it's true. So it's good to recap those things, right? Just to remind people what happened before that. So I'll start about Amazon.com, because that's where the whole journey for AWS itself and the cloud started. So if we talk about in 90s, Amazon.com, online bookstore, that's how we started, an online retailer, and it was a technology company basically. And the way the pace that it was growing at, we used a very big monolithic application and architecture called Ovidus. And it was large, it was slow, it was very reactionary and complicated, right? So anything that you needed to do in there would take a long, long time, because it was one big thing that you had to go and make changes to itself. So
All
we
I would say
started,
is that GIF of the little data tape thing, is amazing. Whoever made that little animation,
I would love
for
to
love
say it's
everyone.
my I did it, but no, I actually not copied, but I borrowed it from one of my colleagues. So yeah, it is pretty cool though. I
Hmm.
loved it. So yeah, we did have tapes running, right? So that's how it was. Big spindles going around, round and round. And fun fact, Amazon.com itself grew so large around that time that we had to buy one of the largest or the fastest computers in the world. And at one point, we had the supercomputer, which ranked at number 5 in the world for running with just one website, essentially, if you want to call that. So we didn't want to do that. We didn't want to keep spending money on buying larger and larger computers. So one of the things that that happened at that time was Amazon itself started expanding, and we started offering our technology to other companies. So we had this platform called Merchant.com, and where we wanted other retailers like Target and Marks and Spencer to come and sell their products on there. But the problem we face there is that making changes to our existing platform and our existing technology to enable that was very, very difficult. And so at that time, we had our CEO, Jeff Bezos. He asked Andy Jassy, who is now the CEO of Amazon and who was the CEO for AWS for quite a long time, to go and investigate why it is taking us such a long time to create these new business functions or new capability within our platform itself. And some of the things that Andy came back with and realized is that each new project that we wanted to do within Amazon.com was pretty much like reinventing a wheel, because we had one big monolithic application. And if you wanted to create a new project, we just had to start from the beginning. Second one was our systems were complicated, brittle, and hard to change. So if you had to make a change, you had to go through the whole cycle of making sure it will fit in the existing ecosystem and the existing applications and functions. So it took a very long time. And the last one was, again, because of that, very new features were very, very slow to release to our customers and our partners themselves. So from then on, we started working on a few things. One of the biggest one that we always talk about is that, the two pizza teams and everything had to be an API, so service-oriented architecture. So we divided all of our applications into smaller bits of application um, functions, and each had to talk to each other using an API rather than direct calls. And I mean, there's a lot of talks around how we innovated in that space, but that's where it came from. That's how we thought of innovating from that perspective.
And quite interestingly, all of those realizations are still very much a problem in modern like businesses as well. Like not only just legacy systems, it's like any system that is built in a rush, to prove market fit and get the MVP will run into these exact same problems and realizations, and then essentially having to be approved upon once they do actually hit that market fit.
Mm. Yep, that's exactly right. So some of the decisions that we made out of that was is as a business as Amazon, we wanted to spend less time on looking after IT and building and managing it, and we wanted to spend more time on releasing new features, right? We want to grow our business, so we want to spend more time on releasing new services and features for our business itself. We wanted to standardize and simplify, how the applications are built itself. So that's what I talked about, the two pizza team and having the service-oriented architecture itself. And once we gone through that phase and once we had that mindset and those patterns developed within Amazon.com, we were pretty good at that time running our own infrastructure, and quite a lot of that was pretty much automated because it was repeatable. So at that time, we thought, why don't we use our skills and benefit other businesses around the world and provide them the same capability that we currently have at the moment? And that's how sort of AWS was born. So in 2006, we started releasing our first services, and the rest of it is pretty much a history. So that's the background on AWS and how cloud came to be. Let's now talk about a bit more about cloud computing itself, if we just talk about cloud computing, what it is. So in terms of pure definition of cloud computing, it's basically an on-demand delivery of IT resources via the internet with pay-as-you-go pricing, right? And it provides an easy access to services like compute, storage, databases as base services, and then you have other services which are built on top of those other the base services, and they're called higher level services. Managed RDS instances or NoSQL databases like DynamoDB and all that are built on top of it, and then we have machine learning and everything else that goes with it. So that's basically cloud computing itself. And currently, if you look at number of services, I mean, these are the building blocks. AWS has more than 200 plus services at the moment. And if not counting from the looking at the last reInvent that it just happened a month back, we probably have a lot more now. And it's very easy to lose track of them.
Yeah, but the journey pretty much is the same for every customer, really. It's the utilization of it's always going to be networking, compute, storage, databases. Like that's what everyone starts off with, and generally one account. And then from there, they have to then go into the multi-account pattern and then machine learning analytics. Actually, generally analytics first, because it's very hard to do machine learning if you have no idea what your data is.
Yeah, that's right. I mean, we can talk about that quite a bit from that perspective for sure. But let me just sort of talk about some of the benefits of using cloud, right? We're talking about the basics of cloud. One of the biggest things that everyone talks about, and it holds true, is that it eliminates the undifferentiated heavy lifting. And by that we mean is that you shouldn't be doing things that is not core part of your business, right? So if you're a retailer, you shouldn't have to worry about looking after your data centers. You shouldn't need to be an expert in running data centers, the cooling systems, the power, everything else. Someone else can do that better. And one of the examples that we always give to our customers is if you look at back in the history in 1800s, when the whole industrial revolution happened and we had the traditional factories that were running at that point in time, and they needed to be run a lot more efficiently, so you had electricity, and each factory pretty much had their own generator to provide their own power in those factories. the problem with that was they were very expensive, generators itself for providing electricity. And that wasn't part of the core skill set of those businesses. They were retailers, or they were, well, not retailer, but they were building different products. They were not expert in running generators and creating electricity. So that at times took them away from their business itself, and they would spend a lot of time in fixing those things. And with time, we had power companies come in, right? They had centralized power plants, and they would then provide electricity back to the factories. And what happened with that is the electricity was a lot more reliable, it was less expensive, and they always had the capacity to meet the growing needs of the factory itself. And the other advantage of that was when you actually outsource that part and get someone else who is going to be an expert in looking after and managing that part of the business. In this case, is providing electricity. Any new innovations that come along, so things like the wind power and the solar power, that is now managed by that other party who's really good at doing that part of it. And all those benefits are provided back to you. So now the factories and businesses can actually demand from those power companies to provide them sustainable power, right? So we have businesses now asking the power companies to say, hey, I only want to send power itself, so it has to come from renewables like wind and solar itself. So those innovations that are happening at the power companies are pretty much being passed on to those businesses without the businesses having to innovate those things on themselves. So that analogy, if you look at that and compare to from IT perspective, and look at the traditional on-premise data centers, so there's something similar is happening in that sense, is that businesses shouldn't have to look after the data centers. They are not expert in running the data centers, and no, they should be, right? Their business or their core skill set is different to running those data centers. So if you look at traditional data centers, you always have a primary and a secondary data center, primary being the main one where everything runs. And the idea is that you have a backup and a standby data center where everything will fail over if in case something happens to the primary one. But in reality, it's not always the same. The standby data center is never equipped with the same amount of compute, storage, networking, and very rarely you will see companies who will be doing that testing to make sure that actually switchover happens successfully from one to another. And there are countless examples in the past where it really hasn't worked well when the actual outage happens in the primary data center itself. So from AWS perspective, again, just going back to basics on how we design our region. So currently there are around 30 regions around the world for AWS. So region is a geographical location, and each region consists of multiple availability zones. And each availability zone then in turn consists of multiple data centers. And the idea of having different availability zones within a region is to provide that redundancy for you and high availability. So each availability zone will be getting a separate power from different power providers. It'll be getting a separate and redundant network connections from different network providers. And then there will be interconnectivity between all the availability zones and in that region itself. And the idea behind having these availability zones within a region is that they can provide that high availability for your application. So you can spread your application and have it running in multiple availability zones and still get that single digit millisecond latency, so you can run them synchronously. And they're far apart enough and have redundancy built in so that if one of them goes down, it's not going to affect your application, and your application can still keep running on the other availability zone within that region itself.
And that just reminded me, Melbourne, I think, went live yesterday.
Yeah, I was going to talk about that as well. So yeah, Melbourne, one of our regions in Australia. We already have the Sydney one, which has been there for almost 10 years now. So the Melbourne one's long time coming is now gone live officially. meaning that now our customers can actually take advantage of that and have that multi-region DR or a backup if they need to provide the back to the critical applications if they needed to. And also, we have customers who are in Melbourne, then they can really take advantage of having that local data center, local region to actually use it as an extension of their existing on-prem data center, and have that low latency that it provides from that perspective. And it goes for our New Zealand customers as well, right? If you most probably you would be running your applications and workloads in Sydney region. Now you can take advantage of the Melbourne region as a backup region in terms of you know copying your backups to there and using that as a DR if you require to from high availability perspective for your applications themselves. Cool. Now, when you talk about AWS, number one thing that we always focus on, and we say that it is job zero for us, is security. So we don't compromise on security. Security, then operational excellence is as alongside that. But security is always job zero. Because one of the things that always comes into mind, especially when early days of clouds, I mean, Casey, if you remember or not, right? One of the biggest thing was we don't know if it is secure or not, right? People are used to seeing their hardware and they know where it is. They can go touch and feel it, and they know what security is around that and all that. But then the whole idea of, it's being managed somewhere else in Australia, and is it secure enough or not? So from that perspective, it's a bit of counterintuitive to think that the cloud would be more secure, but it actually is because we have to go through all the compliance and certification to make sure that our cloud services are as secure as any other in the world. And we have third-party auditors who regularly audit our infrastructure as well as services to make sure they're compliant to those standards. And these are standards I'm talking about, bank standards, financial ones, other regulations, from power companies, from health, and even, we have from the governments themselves as well. So our infrastructure itself is certified and compliant to those standards.
And physical security of a data center is generally the most important aspect of
Yeah,
it.
so it's security at different layers, right? So physical start off with, and then as you go through the different security to services as well. And I mean, as I mentioned before, we have customers from military to global banks to other highly regulated organizations like health as well, running their workloads in our clouds. So as we talk about security, so one of the things or the concepts that we want our customers to think about is this shared responsibility model. And the idea behind this is that AWS is responsible for security of the cloud. And by that we mean is AWS is responsible for the infrastructure, right? So we are responsible for the physical security, as Casey mentioned, of our data centers. We are responsible for the basic services like the compute, storage, networking itself, power, and everything else that goes with it. And we like to think our customers are responsible for security in the cloud. And that's a bit of a spectrum in terms of which services that they use. So if our customers are using a higher level services like the DynamoDB, for example, then they have a less responsibility of the whole stack for that service than if they were, for example, running an EC2 instance. So with the DynamoDB, AWS would be responsible for making sure the OS is secure, the VM is secure, is patched, all that's happening in the background. Whereas if a customer was running an EC2 instance, then the customer has a bit more responsibility for making sure that the OS that they're running on that EC2 instance is more secure, and they're patching it, and they're making sure the right security groups are enabled and all those things that go with it. So what we tell our customers is to think about which services you're going to use in AWS very carefully, because then your responsibility for that security changes based on the service that you have chosen. Do you want to add anything to that, Casey?
No, it's all good.
Great. So yeah, just think about what which service that you're using. And the other part is the configuration of those services as well. So from AWS perspective, we provide our customers tons of services from security point of view to make sure their applications are as secure as possible. So these are things like the firewall, the networking, encryption, everything else that you can think of in that suite of services from security perspective. So we want to make sure our customers have the knowledge and the training provided to use those configurations properly as well. So that all comes under the security in the cloud from a responsibility perspective. So now that we talked about cloud computing itself, let's talk about some of the main benefits of cloud computing. So number one is agility, right? That's the biggest one. So with agility, you can really innovate in the cloud. So from business perspective, if you have a new idea, you can really run with it in the cloud and scale it at a global scale very, very quickly. So I'll give you a bit of an example on what I mean by that. So if you look at the traditional data center challenges, right? If you have a new idea, you want to provision something, you will need to actually get the physical equipment in the data center, right? And it will take quite a long time, at least 2 to 3 months to get the equipment, order it, physically go plug it in, and then use it. Also, you have a limited ability to scale that up. So, if you have a new application that you just come up with it, you deployed it, and now you have, 100,000 users, and it's gone gangbusters, you can't really quickly scale that up. You need to then order more equipment. It's going to take time, and you can always get to the capacity limits of how much you can put in a physical data center as well. So just walking you through a product launch, an example. For example, you have a new idea, a new project, and you want the IT to work on it. You want them to provision the physical hardware and the resources required to run that. So this is just a traditional to-do list, right? That you have to do, or your procurement department have to do, or your infrastructure teams have to do to actually get the physical hardware in. So yeah, it takes it a while.
Yeah, I lived through it. It was painful.
Yeah.
Very painful.
Yeah. And yeah, imagine your product was successful and then you need to add more capacity, and then another 3 months later you have more service.
It's even worse when the database is a bottleneck.
Yeah, and again, going back to the example of what Amazon.com came across was we just got to that scale that we couldn't really get bigger hardware. As I mentioned, like we had world's fastest supercomputer at Amazon.com running, which is very interesting. So we ran into the same challenges ourselves. Now compare that to running that in a cloud environment, right? What you need to do, just execute a script. It will set up new service for you. That's it, in minutes. And now if you need to increase capacity, yeah, execute another script. And again, it'll just bring up as much resources as you want. So you can see what the difference is in those two, right? That's what we mean by agility itself. And the second one is elasticity. And if you look at capacity planning, when you have a new application being used, you always do a bit of forecasting, what the capacity from the infrastructure perspective is needed to serve the customers for that application. And, there's always something like that, that's the predicted demand. But when you are serving that predictive demand, and you need to do it in a traditional way, you would have to spend quite a bit of money to get, certain number of servers. And then it's obviously large capital expenditure, and then your demand will catch up to the capacity that you currently have in place, and then you buy another number of servers, and then demand will catch up with that capacity again. And in actual demand itself, obviously will be going up and down, but you need to spend a lot of money buying that hardware because you can't really keep buying hardware. As I said, it takes like a few months for it to get in there and get in place. So at any given point, you're always either over provisioning or you don't have enough capacity, right? So you're spending money on the hardware that you can't use, or you just don't have enough hardware because it takes that much time to get new one.
And more importantly, it's actually the opportunity cost that you're losing out on, because all of that website traffic that you can't serve, or people that can't engage with your marketing, like that's the true cost. Because that hurts your business, because now you're seen as unreliable. That sticks to your brand.
Yeah, exactly. So I mean, nowadays everyone expects the application to be scalable. You shouldn't run into load issues, and you can't really go back and tell your customers, hey, wait, we can't get more users in because we need to get more hardware, right? So the expectation and the norm now is that application that you're launching or any service that you're providing to the consumers, it's infinitely scalable. So with cloud, you can then match your capacity with the demand that you have. So it can go up and down as the capacity and the actual demand increases or decreases. And that's where we talk about scaling. So traditionally, we've always been vertical scaling. So by vertical scaling, I mean is you have a server which got two CPUs and 16 gigs of RAM, and now you got more users and you need more capacity. You will scale that up. You will get a bigger VM. You'll get like uh, some VM with 16 CPUs and 256 gig of RAM. The problem with that is you can only do so much, and you're also increasing your blast radius in the sense that now you have just one server. If that goes down, a lot more users will be affected compared to if you're going with something like horizontal scaling. That's what we recommend our users to do, which can be automated in the sense that you can have smaller servers but a lot more of them, so that you can have smaller step scaling as well as your blast radius is quite less in that perspective. And that's what cloud helps you do, is to actually automate that scaling in a horizontal fashion rather than doing it as a vertical one that you normally would have done on an on-prem data center.
And I also know companies that do both, based on what compute is available and at what prices based on spot.
Yeah, I mean, nowadays, to be honest, in the beginning, like a few years back, I would think there was only choice of, you can only scale based on this compute size, right? You can't mix and match. But nowadays, with our auto scaling service, it's quite advanced, to be honest. You can actually now choose different types of servers. You can choose servers with different, CPU or memory sizes, as well as different architecture if you needed to actually help you scale, and the pricing perspective as well. We can do spot pricing as well, right? Now, Casey,
Yeah,
using
yep. So you
spot
can do fleet
instances.
managers. Yep.
Yep. So yeah, there's a lot more options available now.
And that's why some companies do both, because they'll use spot pricing based on capacity. And that means that sometimes the bigger instances have more capacity to them, so they'll provision that, but just put more instances of their solution on that one instance.
Mm-hmm. That's true. And other benefit we have for cloud is the cost savings. So if we talk about cost itself, on a traditional data center where you have to increase the capacity in a big steps, you have to spend a lot of money. And from the business perspective, they always like to have an OpEx cost rather than a CapEx one, because you have to bring a big chunk of money, and the business might not be making that much money, but you need to put that in because you expect to make that much money. Whereas with OpEx, you can just pay as you go. And that's what cloud provides, right? So if your business is growing, making more money, you pay more money to run the IT infrastructure, so you don't have wasted money sitting there not doing anything. Also with the cloud, there's improved transparency for the cost and the usage, because you can now see what each and every component of your application is costing you, the networking, the compute, the storage, and everything else. If you look at the traditional data centers, it's like one big clunk. It's one business unit who is responsible for the cost. The application teams don't even need to know the cost, and sometimes that could be challenging, because then the application teams are not working or not aware of the changes that they can make will actually end up saving the company some money. So now you can actually have very good visibility of what each of your applications are costing, and you can do things like show back to the team, so that teams are not responsible for, even if they're not responsible, at least they have a bit of view. Hey, our application is actually costing us that much money, so that we can improve the application code itself, or we can change a few things in the application so that it costs less to run.
Yeah.
So
And just to quickly answer a question, you can hit me up or Imran up directly on LinkedIn to get access to slides, but this will be on demand after the stream ends in probably about 10, 20 minutes. So, just feel free to come back. It'll be available on Twitch in the on demand section for the next 28 days, I believe it is.
Cool. Sorry, I can't see the chat. So.
And there's also no one. So it's like more customers ask me about the comparative cost and performance between AWS main services, S3, Redshift, DB, and General Lambda, and the Google environment. So essentially the competitors, which is very common as well. We get that a lot. And that's where it really comes down to doing due diligence. The pricing for all of them are publicly available, and benchmarks for all of them. And just that's where they say utilize the third party, a source of information that you can, like Gartner and all that stuff, and make your conclusion based on that. The one that aligns most of your business and the vision that you're trying to achieve. And ultimately, what are the costs? Because you can do a cost breakdown, because again, all the pricing is public. So there's a lot of third party, and I'd say read the Gartner reports, especially if you want to get a breakdown of performance and or how the market sees the big three cloud providers.
Cool.
Do you have anything to add to that, Imran?
No, I think you put it nicely. Yeah, all that information is publicly available. So yeah, do your due diligence and go through that. The other one, the fourth thing that comes to when we're talking about cost savings is the upgrades and maintenance fees. I mean, you will be surprised how much it takes to actually run physical servers in the data centers. Nowadays, there are a lot of automation available, and you can do that. But things like, just the firmware updates, the patching, the physical changes to it, it takes a lot of manpower and a lot of time to get that going, and make sure that actually up to scratch. And we have seen that in some of the recent ransomware attacks. Not attacks, but vulnerabilities that have been found in the firmware for some of the servers, and I've seen that in organizations which who manage their own equipment. It takes weeks and weeks to get all that updated, and sometimes it's not even all of it updated, but it requires a lot of manpower and money to actually have everything updated. So with the cloud, it's a bit difficult. Well, it's a bit different in the sense that AWS would be managing it depending on which service you're using. But just being in the cloud, we have to have everything automated. And because of scale that we are at, we normally spot those vulnerabilities long before anyone else would. And mostly those vulnerabilities are reported to us before they go public as well. So we make sure that all of our services are patched up and secure and maintained before any other bad actors have a chance to actually exploit those vulnerabilities as well. So just keep that in mind too. And lastly is global scale, right? As we grow, as AWS grows, its economy is to scale. So as we get more and more hardware and as we get more and more regions, we keep passing those savings to our customers. So I think if I'm not wrong, since the invention of AWS itself, since we have passed about 150 cost reductions to our customers for different services. So as we grow and as we get more and more users using our services, the cost of operating and provisioning those goes down, and we pass that on to our customers.
It's also very important to keep in mind that costs change on region. So, for example, a lot of people that I talk to in New Zealand that use the Sydney data centers, I say, well, you don't actually generally need your dev or test environments in Sydney. You can actually host it in Mumbai or one of the US data centers, and straight off the bat, you'll be saving 20%. Like without actually doing anything. So it's very important to also be aware that the fact that the pricing is global as well. So each region has different pricing.
Mm. And that again comes down to the scaling, right? Each region has different reasons and it costs us differently for running those regions. So it could be
Yep.
manpower, it could be equipment, and it could be the scale as well, right? That's all that affects.
And it's very important to understand, like, how to structure your solutions to get the best out of those cost savings as well.
And we at AWS really work hard to make sure our customers are not actually spending more than they need to. And in fact, it's actually one of our goals to make sure our customers are cost optimized. So we really work closely with our customers and go through the workloads, making sure they use the right services and they're pulling the right levers when it comes to cost savings. So these could be reserved instances, spot instances, all that. So if you have any concerns or if you'd like to get your workloads reviewed, so please reach out to your AWS account exec or anyone else for that matter.
And if you don't know or who they are, just fill out the contact us form and someone will ring you and then put you in touch with the correct people.
Cool. And the last one, I really like this one, which is, deploy globally within minutes. One of the things that we always had is, as if you're a SaaS company or if you're a startup in New Zealand, you're coming up with some awesome idea, right? That you would set it up. Let's say I'm talking about pre-cloud era, in your traditional data center, and now you need to go global. You would not be able to go global that easily. It's going to take you very, very long time to create partnerships and deployments and everything else to do around the globe itself. But now with AWS and for that matter, other cloud providers, you can go global in minutes because we have that global infrastructure. As AWS has got the largest one in the sense that we have 30 regions and we have more coming up as well. I mean, on this slide, it says Melbourne is announced, but it's not. It's live now, so I should change that. But the other ones we have coming up is Canada, Tel Aviv, Thailand, and Auckland as well. That brings me to our New Zealand region. So that is being launched in 2024. That's investment from us, about $7.5 billion, which is quite a lot of money. And we expecting to provide around 1,000 full-time jobs as part of it as well. We currently still have presence in New Zealand. So we got 2 physical offices, Auckland and Wellington. We also have POPs, which is our caching locations for CloudFront service as well. And we also have local zone being coming live this year too in Auckland. So yeah, quite a bit happening in New Zealand too.
Which is always good to see, especially because I guess we're biased in that regard since we are located in New Zealand.
Yep, definitely are biased. And look, I mean, to be honest, when this was announced, I was quite surprised that little old New Zealand is getting a region, which is quite a big deal. Cool. All right. So that's all I have. Any questions, Casey, from our audience?
There's been some robust discussion in the comments, which is always
Oh,
like
that's
great
good.
to see. I like
Awesome.
that level of engagement. At the end of the day, I always say for people to reach their own conclusions and read those like third party bits of information, because that's where you're going to get the most out of it.
Awesome.
Awesome. So we'll just hopefully, I think this will be our slot going forward, as I mentioned at the very beginning. But I noticed that we have had a lot of people join and leave during that time. So just to, so we are weekly at this time slot. So it's like 1 p.m. New Zealand time. I believe it is 6 or 7. I can't remember. We've not Pacific Standard Times and daylight savings or not. I think that might be May. But yeah, so we'll be streaming this every week. So we'll have different people either from AWS, like Imran here, or we'll have people from our partners or someone from the service teams to actually do proper deep dives. We just really like starting the year off with this Cloud 112, as Imran said, to recap and actually just, let everyone start off that state. And I also know that not everyone is experts in cloud technologies, so it's always good to just have this level setting. So thank you very much, Imran, for your time and actually taking us through this journey. So I do appreciate it.
Awesome. Thank you, Cassie. Thanks for having me, and hopefully everyone found that useful.
Yep. And everyone, please enjoy your weekend. And if you're located in Auckland, enjoy your long weekend. Cool. Mate wa.
Right. Bye for now.